Mars. The very name evokes wonder. A celestial neighbour shining brightly, a crimson beacon drawing our curiosity. Its reddish hue hints at a world both alien and familiar. For centuries, humans have wondered, what secrets does it hold? What mysteries lie beneath its dusty surface? Of all planets, it is the most Earth-like, a chance to establish a second home for humanity. But the journey is fraught with challenges. Harsh conditions and vast distances stand between us and Mars, yet the human spirit is persistent. The lure of Mars is a call we cannot ignore. The dream of reaching Mars is not new. It has captivated the minds of scientists, writers, and dreamers for generations. From early astronomers sketching its surface features to science fiction authors weaving tales of Martian civilizations, the red planet has held a special place in our collective imagination. In the early 20th century, visionaries like Konstantin Tsiolkovsky and Robert H. Goddard laid the groundwork for space travel, their ideas fueled by a desire to one day reach Mars. Their work, though seemingly fantastical at the time, paved the way for the space race and the eventual landing of humans on the moon. The Apollo missions, while focused on our own satellite, also served to ignite our Martian aspirations. If we could conquer the moon, then surely Mars was within reach. With renewed vigor, scientists and engineers turned their attention to the challenges of interplanetary travel, developing new technologies and refining existing ones. Today, the quest to reach Mars is more than just a dream. It is a tangible goal. Space agencies around the world, both public and private, are actively developing the capabilities needed to send humans to the red planet. Ambitious missions are being planned, timelines are being drawn, and the dream of setting foot on Martian soil is edging closer to reality. But the journey to Mars is not merely about technological prowess, it is about pushing the boundaries of human endurance and ingenuity. It is about facing the unknown with courage and determination, driven by a thirst for knowledge and a desire to explore the cosmos. The challenges that await us on Mars are immense, yet the potential rewards are even greater. The call of the red planet is strong, and humanity is preparing to answer.
Reaching Mars is a feat of extraordinary complexity. Unlike hopping to the moon, a mere stone's throw away in cosmic terms, a journey to Mars requires us to bridge a vast gulf of space. The distance between our two planets is constantly in flux, influenced by our elliptical orbits around the Sun. At its closest, Mars is approximately 34 million miles away. This might seem insurmountable, but consider this. At their farthest, the two planets are separated by an incredible 250 million miles. This astronomical distance presents a daunting challenge for even our most advanced spacecraft. Current technology limits our travel time to Mars to around 7 months, a significant portion of an astronaut's life. Overcoming these challenges is paramount to the success of any manned mission to Mars.
The journey to Mars doesn't just test our engineering, it challenges the very fabric of our being. Space, a seemingly empty void, is a surprisingly hostile environment. The most immediate threat is the vacuum itself. Here on Earth, we take for granted the air we breathe, the pressure that keeps our bodies intact. In space, there is no such luxury. Exposed to the vacuum, an unprotected human would face a swift and gruesome demise. To survive this unforgiving environment, astronauts require sophisticated life support systems. Maintaining these systems, ensuring their constant functionality, is critical to the survival of any Mars mission.
The dangers of space travel extend beyond the immediate threat of vacuum. Our Sun, the life giver, also bathes the solar system in a constant stream of harmful radiation. This cosmic radiation, composed of high-energy particles, poses a grave risk to human health. Prolonged exposure can damage DNA, increasing the risk of cancer and other radiation-related illnesses. This is particularly concerning for missions to Mars, which necessitate extended travel times outside the protective shield of Earth's magnetic field. Adding to this danger are solar flares, unpredictable eruptions of energy from the Sun. Developing effective shielding and early warning systems for these solar events is vital for protecting future Martian explorers.
Having crossed the immense chasm of space, our intrepid explorers face a new set of challenges upon arriving at Mars. The red planet, though seemingly familiar in its rocky embrace, possesses a gravitational pull vastly different from our own. On Mars, you'd feel lighter, as if a weight had been lifted from your shoulders. This is because the gravity on Mars is about 38% that of Earth's. While this might sound appealing, this difference in gravity has profound implications for the human body. Astronauts accustomed to the constant pull of Earth's gravity would need to adapt to this new environment. Their muscles and bones, no longer subjected to the same forces, would weaken over time. Understanding and mitigating the effects of reduced gravity is crucial for ensuring the well-being of future Martians.
The Martian atmosphere, a wisp compared to Earth's life-giving blanket, presents its own set of challenges. Composed primarily of carbon dioxide, it offers no breathable air for humans. Venturing outside requires specialized suits, providing not only oxygen but also protection from the harsh Martian elements. The thin atmosphere also provides little shield from the sun's radiation, making exposure a constant concern. Temperatures on Mars fluctuate wildly, plunging below -200 degrees Fahrenheit at night and rising to a balmy 70 degrees Fahrenheit during the day. These extreme swings necessitate robust thermal regulation within habitats and suits. Adding to the environmental hazards are Martian dust storms, which can engulf the entire planet. The fine electrostatic dust can infiltrate equipment, disrupting sensitive instruments and potentially posing health risks to astronauts.
Despite these challenges, the dream of establishing a human presence on Mars persists. Scientists and engineers are actively exploring ways to transform the Martian environment, making it more hospitable for human life. One such concept is terraforming, the process of altering a planet's environment to make it more Earth-like. This could involve introducing microorganisms to convert the Martian atmosphere into breathable air, or melting the polar ice caps to release trapped water, creating oceans and fostering a more temperate climate. While terraforming remains a distant goal, it serves as a testament to human ingenuity and our unwavering desire to push the boundaries of what's possible.
Imagine a future where humans have established a foothold on Mars. The image of a barren red landscape transforms into one dotted with habitats, greenhouses, and research facilities. Survival on Mars hinges on our ability to produce food, not just for sustenance, but for psychological well-being. Martian soil, lacking the organic richness of Earth, presents a unique challenge. Scientists are exploring innovative farming techniques, such as hydroponics and aeroponics, to grow crops without traditional soil. These methods use nutrient-rich water solutions, minimizing water usage, a precious commodity on Mars. Genetic engineering also plays a crucial role. Researchers are working to modify crops, making them more resilient to Martian conditions, tolerant to the high salinity of the soil, resistant to the intense radiation, and adaptable to the lower gravity.
The human journey to Mars is not just a physical voyage, it's a profound psychological undertaking. Confined within the walls of their spacecraft and habitats, Martian pioneers would face the daunting reality of isolation, far removed from the comforts and support systems of Earth. Communication with Earth, though possible, would be delayed by the vast distances. Imagine waiting 20 minutes for a message to reach Earth and another 20 minutes for a reply. This communication lag would impact every aspect of life, from routine interactions to emergency situations. The psychological well-being of Martian settlers is paramount. Virtual reality could offer immersive experiences, simulating the sights and sounds of Earth, helping to alleviate feelings of homesickness and isolation.
Looking even further ahead, we envision a future where children are born and raised on Mars. These Martian-born humans, having never experienced Earth's gravity, would represent a new branch in human evolution, physically and perhaps even psychologically distinct from their Earth-bound counterparts. The lower gravity on Mars could lead to physiological changes. Will they be taller, their bones less dense? How will their cardiovascular and immune systems adapt to this new environment? These are questions that can only be answered over generations of study. The ethical implications of raising children on Mars are profound.
Establishing a permanent human presence on Mars necessitates more than just the basics of survival. It demands the creation of a self-sustaining Martian economy, one that can provide for its inhabitants without constant reliance on Earth. This means developing industries on Mars, utilizing the planet's resources to create goods and services. One of the most promising avenues is Martian mining. The planet's crust is rich in minerals and elements vital for both construction and technology. Iron, titanium, and aluminium are abundant, providing the raw materials for building habitats, infrastructure, and even spacecraft. Water ice, found beneath the surface and in the polar regions, is another crucial resource. It can be extracted and processed to provide drinking water, oxygen for breathing, and even rocket fuel. This makes Mars a potential refueling station for future missions deeper into our solar system. The development of Martian industries will require innovation and adaptation. The Martian economy, red planet, blue chips. As Martian industries emerge and mature, they will form the foundation of a Martian economy, one potentially vastly different from our own. With limited resources and a harsh environment, efficiency and innovation will be paramount. The scarcity of certain resources, coupled with the challenges of transporting goods between Earth and Mars, will drive the development of closed-loop systems. Recycling and resource conservation will be essential, not just for sustainability, but for economic viability. The Martian economy might also see the rise of new forms of currency and financial systems. Digital currencies, already gaining traction on Earth, could play a significant role in facilitating trade and transactions in this new frontier. Imagine a future where Martian companies, specializing in areas like robotics, resource extraction, and advanced materials, become major players in the solar system's economy.
Governance on Mars. Writing the Martian Constitution, the establishment of a permanent human settlement on Mars raises profound questions about governance and societal structures. How will this new Martian society be governed? What laws and principles will guide its development? The distance from Earth necessitates a high degree of autonomy. Martian settlers will need to govern themselves, making decisions that impact their lives and their future. This raises the possibility of new forms of democracy, perhaps more direct and participatory than those on Earth. The Martian Constitution, drafted by the colonists themselves, would need to address a range of complex issues. Resource allocation, environmental protection, conflict resolution, and the rights of individuals in this new society will require careful consideration.
A future written in the stars. The journey to Mars is humanity's next great adventure, a testament to our indomitable spirit of exploration and our insatiable curiosity about the cosmos. It is a journey fraught with challenges, pushing the very limits of our technology, our ingenuity, and our resilience. Yet the rewards are immeasurable. The chance to unlock the secrets of our celestial neighbor, to search for life beyond Earth, and to secure the future of our species. Imagine standing on the surface of Mars, gazing up at a sky ablaze with stars, the Milky Way, a shimmering band stretching across the heavens. The air is thin, the silence profound, broken only by the hum of life support systems. Above you, two moons, Phobos and Deimos, dance across the night sky. You are standing on a new world, a pioneer in a new frontier. The pale blue dot in the Martian sky. From millions of miles away, Earth is a pale blue dot in the vastness of space. A humbling sight, reminding us of our place in the universe. Challenges on Earth seem distant yet familiar. Mars exploration fosters innovation and collaboration, shaping our future. Section 3, the next giant leap. As we venture into the cosmos, we carry our technology, values, hopes, and dreams. Establishing a human presence on Mars is about expanding human consciousness and creating a new society. Children born on Mars will inherit this legacy. They will grow up under a different sky, shaped by Mars' gravity and unique challenges. They will be the true Martians, pioneers of a new branch of humanity. The journey to Mars is a testament to our belief in a future where humanity reaches for the stars. It will test our limits, inspire dreams, and redefine what it means to be human.